Hey everyone, welcome back, and today let's solve Leetcode problem 2270 titled Number of Ways to Split Array. So we're given a zero-indexed integer array nums of length n, and nums contains a valid split at index I if the following are true. So the sum of the first I plus 1 elements is greater than or equal to the sum of the last n minus I minus 1 elements, and there is at least one element to the right of I. And so that is I is strictly less than the length of nums minus 1, basically the last index, and it's greater than or equal to 0. So we need to return the number of valid splits in nums. So in example 1, we have our input array nums to be 10, 4, -8, and 7. And in this case, there are two different valid splits that we can make following these criteria here on our input array nums, right? And it says there are three ways of splitting nums into two non-empty parts, but only two of them are really valid. Let's go ahead and take a look at which three ways we can actually split it into and which two ways are actually valid based on these specific criteria. So the three ways we can actually split nums into two non-empty parts, whether they're valid or not, is we can split nums at index 0. So the first part would just be this index 0 of 10, and the second part would be this 4, -8, and 7, right? And in this case, the first part's sum is just 10, right? Its sum is basically the single element that's in it, which is just 10. And the second part's sum, which is 4, -8, and 7, has a sum of 3. 10 is greater than or equal to 3, and so I at index 0 is actually a valid split. We can actually split our input array nums at index 0 so that the sum of the first elements in this portion are actually greater than or equal to the sum of these last elements here, okay? And what is the next way or valid index that we can potentially split this in? We can possibly split our input array nums at index 1. Or I is basically equal to 1. And if we do that, then our new first part would become 4, 10, or 10, 4, and the second part would then become -8 and 7. In this case, 10 plus 4 is 14, and -8 plus 7 is -1, and 14 is still greater than or equal to -1. It still fits the criteria, and so splitting at index 1, or when I is equal to 1, of our input array nums in this example is still valid. Now, what if we choose to split at index 2? What happens then? Well, if we split at index 2, the first part would then become 10, 4, and this -8, right? And the second part would just be this singular 7. In this case, 10 plus 4 plus -8 is actually not going to be greater than or equal to just 7, right? And let's just kind of compute this ourselves. What's 10 plus 4? It's 14. 14 minus 8 is 6. 6 is not greater than or equal to 7, which is the sum of the second part, and so this is not a valid split at this index 2. And you may be thinking, okay, well, why can't we split at index 3 at this 7? Well, think about it. We have to make sure for it to be a valid split that there is at least one element to the right of I. If we split at index 3, that is the last index in our input array. We can't find any elements to the right of the last index, and that's why that index I has to be at most one less than the last element, or in other words, it can be up to the second to last index. So these are the three potential splits that we can make, and in this case, only two of them are actually valid splits. In example 2, applying similar logic here, we also have exactly two valid splits, right? And there are exactly two valid splits in the input array nums. Either we can split at index 1 for it to be valid, then we'd have 2 plus 3, 5, which is greater than or equal to 1 plus 0, 1, or we could split at index 2, then we'd have 2 plus 3 plus 1, which is going to be 6, or and we'd have 2 plus 3 plus 1, which is going to be 6, which is greater than or equal to 0, and so those are the only two valid splits that we can make. If we split at index 0, let's think about it. If we split at index 0, although that is possible, well, we'd get a sum of 2 for the first part, and we get a sum of 4 for the second part. 2 is not greater than or equal to 4, and so that would not be a valid split. Hence, there are only two valid splits that we can possibly make in our input array nums. So for the constraints of this problem, as you can see, the length of our input array nums is not going to exceed 10 to the 5th power, and we're going to have at least two elements to even make a valid split anyways. And for every single value in our input array nums at any index I, it is going to be between -10 to the 5th power and +10 to the 5th power. So with that problem statement, examples, and constraints out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so what is one little quick observation that we can make to really kind of make our solution a lot more efficient and help us even lead to that solution? Well, notice that instead of actually calculating the sum of both parts for every split, we really can optimize this by basically just first computing the total sum of the array. And if we do that, well, then that allows us to actually calculate the sum of the right part, which would just be the sum of the right, which is going to be the total sum minus the sum of the left. Right, that's going to give us the sum of the right part of our split at that actual index I. So as we actually use this relationship, we can basically just iterate over our array and maintain a running sum of the left part and then dynamically compute the sum of the right part, which is going to eliminate the need of recalculating the sums repeatedly, also known as prefix sums. So for the variables and data structure that we're going to be using, we're just going to basically have a total sum, like we talked about before, to actually store the sum of all the elements in the array, the total sum of our array, to help us calculate the sum of the current right split. And then we're also going to have a left sum to actually keep track of the running sum of the left part as we actually iterate over it. And then finally, we're going to have a ways, basically just integer variable, simply going to keep track of the number of valid splits that we actually find at any valid index I as we actually traverse through our input array as a one-pass solution. So for a quick kind of like high-level rundown of how it's going to basically work, we're first going to compute the total sum of the array, then we're going to initialize the left sum to 0 and ways to 0 as well, and then we're going to iterate over the array exactly once, and for each index I, we're simply going to calculate the right sum, like we talked about before, to be the total sum minus the left sum minus nums at index I. Now, if the left sum is actually greater than or equal to the right sum, only then can we actually increment the ways counter, because that's exactly what the problem tells us, right? The first I plus 1 elements, or the left part of the split, has to be greater than or equal to the right part, those specific corresponding sums. And then we can actually update the left sum by then adding nums at index I, and then finally, just once the loop actually is done executing, once it actually terminates, simply return the count of the valid splits, which we actually store in ways, actually as we actually increment it in our iterations. So with that kind of high-level rundown out of the way, let's go ahead and dive straight into the code here. So what I'm going to do first is initialize my total sum, like I talked about before, to basically just be the sum of our entire input array nums, right? It's simply going to compute the sum of all the elements in an array and then store it again in that integer variable total sum. And let me actually zoom in a little bit. So again, and really what this is going to do is it's simply going to calculate the sum of the right part dynamically at each iteration as we actually traverse the array. So now we're actually going to initialize our main variable's left sum for the left part of the split, and then the actual number of ways we eventually have to return. So both of those variables here are going to be initialized to 0. Right? And to kind of reiterate what those variables actually do, this left sum is simply going to represent the running sum of the current left part, and then the ways is simply going to store the number of actual valid splits, which is ultimately what we actually return once our one-pass for loop is actually done executing. So now let's actually iterate over our array regularly using a for loop here for I in the range of the length of our input array nums and Python here, but there is something that we have to consider. We can't loop through every single index in our input array nums because not every single index is actually a valid split. We have to go up until the second to last index, like we saw in example 1. We can't split at this 7 here because there are no elements to the right of it. We can't actually make a split at index I if it's the last element. And so we have to go up until the second to last element. We're going to iterate over all the indices of our array except the last one, because again, the right part that we actually split into, the right subarray, cannot actually be empty. We have to have at least one element to the right of it to actually make non-empty subarrays. And so this makes sure that we stop at the second to last element, which is going to be linked at nums minus 1. We don't go past that, we don't even hit that. So in every single iteration of this for loop here, as we actually iterate over the valid indices, we want to actually update our left sum. So basically increment the left sum's sum by nums at this current element I, or nums at this current index I. We're adding the current element to the left sum and updating the current running sum of the left part as we actually process through or iterate over our array at each iteration. Now let's actually calculate the right sum to check if we can actually make a valid split at this iteration or at this index I in this for loop here. So how we actually calculate the right sum, like we talked about before in the explanation, it's simply going to be the total sum minus the left sum. Because the total sum, keep in mind, is simply the total sum of our entire input array, and the left sum is going to basically be the sum of the current left part of the array. And we know that the right sum plus the left sum have to actually equal the total sum, because they're basically all the elements together in the array if we actually join them. And so by subtracting left sum from both sides, we'd see that the right sum has to be equal to the total sum minus the left sum, right? Which basically, again, avoids recalculating the sum of the right part from scratch at each iteration, kind of using these ideas of prefix sums. And now we have to actually check the condition if we can actually validly split at this index I. And the way we know that is if the left sum doesn't actually, or rather, it does actually exceed the right sum. And if that's the case, we know that this is actually a valid split, and we can actually increment the number of ways we can actually split it by 1. Because we know that the condition is satisfied, the current index I does actually represent a valid split, and we want to actually increment the ways counter of the number of valid splits we actually have, which is what we want to return, by 1. Because we found another valid split at this current index I in this iteration of the for loop. And once this for loop is done executing, once it actually terminates completely, we simply want to return the number of ways we found and in all the iterations of the for loop here. Because that's going to return the total count of the valid splits stored in our input array nums, right? Which is also stored in ways. So as you can see on the same ID syntax here this should be accepted, there should be a valid solution. And as you can see, this is really just about as efficient as you can get. So to kind of reiterate a quick high-level rundown of how this code actually works, basically we're iterating through the array while maintaining a running sum of the left part, which is stored in the left sum, and basically for each split for each index I in the for loop here, we're dynamically calculating the sum of the right part, which is stored in the right sum, and then checking, well, is the left sum for the current split at index I, is it actually greater than or equal to the current right sum? If it is, well, then we can increment the number of ways by 1, and then the number of such valid splits is going to be returned as the final result, which is stored in this ways integer variable. So for the time complexity of this solution, this really is just going to be a big O of n, or linear time solution. Why? Because, again, n is going to be the size of our array, or the number of inputs or elements we have in our input array nums. And the reason why is because, well, this is really just a one-pass solution. We have exactly one for loop here, and we're going through every single index just exactly once, right? We're calculating the total sum in big O of n, and then iterating over the array exactly once, also in big O of n, for the total time complexity to be a simplified big O of n. And for the space complexity, this is, believe it or not, going to be a big O of 1 solution, because we're really only using a few integer variables like total sum, left sum, ways, and right sum, as you can see here. We're not actually using any auxiliary memory or any additional data structures, and so for that reason, this is going to be a constant time, or big O of 1 solution for the memory or space complexity. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel, and without further ado, I will see you guys in the next video. Bye-bye.